So, a very good afternoon to you all, and thank you very much for joining the session. So, till yesterday, we have completed now the basics of raster image processing. Right. So, we briefly touched upon how do we read raster data. Then we did some elementary pre-processing on the data. Then some image processing terms we discussed, like we discussed about transformation, basic geometric transformation and intensity transformation. Then the third part we discussed where we discussed about spatial filtering and all. So with that, our raster processing part is complete. So today we will delve into a new data processing, like new kind of data processing, like as if you remember in the first lecture it was discussed that geospatial data, there are basically two geospatial data models. Like any kind of geospatial data, there are basically two, broadly if you classify, there are can be represented using two models. One what we call raster data model, and another one we call vector data model. So now we'll talk about vector data model. So as we know that any feature on the surface of Earth, we can that we can be represented using vector raster, or there is another representation for that vector data, and that geospatial data is vector representation, right? So as in case of raster data, we were representing the features on the surface of Earth using a matrix of, or a grid of small cells that we were calling pixels. Now, in case of vector data, we represent the features or Earth surface. You can say the features on the surface of Earth using their latitude, longitude, like by their position, and maybe a combination of these latitude and longitudes, right? Like line, polygon, or polylines. So the representation of features on the surface of Earth using their location, like their by their latitude and longitude, or maybe the combination, multiple combinations of these latitude and longitudes, what we call uh, vector data. Like this you can say this is the route of metro, Delhi Metro. So like these we are representing the different routes of Delhi Metro using vectors. Like every station here, you can see that we are representing using a point, and the connection we are representing, connection between them is being represented by a line, right? So now there are basically, when we represent some earth surface using vector data, then we use three primary data structures. One what we call point, right? So point is a pair of coordinates, like their longitude and latitude, that represent the location of point on the surface of earth, right? So whenever you are representing some feature on the surface of earth by say point, then we will just be representing that, okay, on this particular longitude and latitude, this particular point exists, right? So maybe example of some drop boxes, or example of some very big landmarks, like some big buildings and other things, or it can be anything. Like, so whenever whenever you are representing a feature using point, means we need just its latitude and longitude, its location. Like here you can say these are four different points, and we are representing them by their location. Then what is then sometimes some features can be represented as line as well. Like line is a series of points that represent a line, a series of points that representing a line, that we call a line data structure on the earth surface, right? So example, like we can represent the different the centers of road or rivers, etc., using line line data structure, right? So my, like this, you can say that feature is represented as line, or as maybe a straight line. So polygon, a series of points that define the outer edge of a region. Like suppose if you are representing the boundary of a city or state at different scales, actually we can choose a different representation. Like suppose if you wish to work on very small large scale, depending on that you can choose, like whenever you are representing any feature on the surface of earth using a series of points, right? So that is, and the special property of the polygon is that starting point and ending point will be same, so this is a closed curve, right? So this way we can represent the boundaries of city. Like here you can see an example of vector data representation. Like say suppose this is an area on the surface of earth, and suppose if you are interested only in representing few of these features, right? Like suppose if you want to represent this same way, this may be the river, this road, and there are some trees only. Suppose if you want to represent these using vector data. So like the this river and road, these things we can represent using them represent them using line, right, or line or polyline. And like suppose these trees are there, so individual tree we might represent as something called a point. Like so, depending on our scale at which we are working, we may choose to represent different features using different data structures. Right. So now, how do we choose that when we represent some features using vector data, or how do we represent something using raster data, right? So if our data has clear, distinct boundaries, right? Like if you are saying that the boundaries of a city, that is quite clear, or say if you want to represent some water body, so the boundaries of that water body also generally are clear. Like so, when you have clear distinct boundaries in your data means the data is discrete in nature. Like if you say some thematic maps, wherever you are seeing some classified maps, etc. So for these things vector representation is better suited, right? So whenever you have thematic data or say discrete data that has clear distinct boundaries, so those data can be better, are well suited for being represented as vector data. And data which are continuous in nature, like where there is no clear distinct boundaries between one set of data and another set of data, so there we can represent them using raster data. Like suppose if you want to represent rainfall map across the country, right? So the rainfall, or the pattern of rainfall across the country will not vary in this discrete terms, right? It will be varying continuously, right? So there we can choose raster data representation. Right. So actually, as we discussed in the first or second lecture onwards, that JIDAL is a very prolific library which supports reading and writing both. Right. So, but for vector data, actually, there are much easier libraries compared to JIDAL's OGR. So there is one specific library which I will demonstrate. It's called Geopandas. So Geopandas actually people basically it's quite easy, and it offers very high level interface for handling vector data. In when you are if you work with JIDAL or OGR, actually that is very low level data. You need to know very low level constructs. But so internally these low or in the GeoPandas, these low level constructs will be handled by GeoPandas itself, and we will be working on high level. So I have chosen that we will vector data we will cover using GeoPandas. Right. So before going to GeoPandas, I will briefly discuss about another important library called Pandas, that is adapt for handling tabular data. Right. So because GeoPandas is extension of Pandas for handling geometries. Right. So I will just briefly touch upon the Pandas, then we will go to GeoPandas. So in GeoPandas, basically, Pandas, sorry, actually, basically we'll talk about two main data structures. One is called series, and another one is called data frame. As I said, that GeoPandas is apt for handling tabular data structure, right? So, so every column in your table is represented as something called series. So in Pandas parlance, every column we call as a series, and a group of column together, like entire table together, is called a data frame, right? So data frame, which you can imagine as you said, that data frame which and like your entire data table, right, with named rows and columns, and series is a single column inside that. So for pandas, either first anyway you need to you can install pandas using pip install pandas, or from the conda as well you can install. So these are the same things I am doing here. So that's importing the normally the same things. Now suppose if you want to create a column, like we are creating numpy one dimensional numpy array. Similar way, suppose if you want to create a column with say some values, right? So as we said that pandas series, every column we name as a series. So if you want to create, you need to call like pd.series and pass it a list of values. Like these may be different rows across the rows inside that column. So if I call pd.series like this, so like this it creates a column, right? So data frame. Now when we combine such multiple such multiple such series, then we call that we have created a data frame. Like here, suppose if you are creating two more columns, like one where we are storing the name of the city, and another there some fictitious population around that city. Right, so now we have created here two columns. One is city names and another one is population. Like if I print here names, and if I say print population, so here you can see the population. Now suppose from this you want to create an entire table, right, or data frame. So how do we call, like the counterpart of pd dot series is pd dot data frame. Pd dot data frame. Then suppose if you want to give the column a specific name, like say city name, and the second column, suppose if you wish to give name population and assign them, then here we are passing it these things as a dictionary. So key is our name of the column, and the values are our series. So similarly for the population, key is our name of the column, what we want to give, and the population is the series. Now if I give, so you can see that we created a data frame. Right, so similar way, suppose if you want to, suppose if your data is available in some CSV file and you want to read a CSV file using pandas. So in the here I have a file called stations.csv. So that stores the location of different air quality monitoring stations, or say some automatic weather location of automatic weather stations across Uttarakhand. Right, so that data, if you want to say, so the function for reading a CSV file is pd.read CSV and pass it the name of file. Right, so then you can see, if you see, you read it, it reads it like this, like the entire column can be read like this: station name, station, like maybe the description of station, name of station, latitude and longitude of that particular station. Like, so this way we can read a file using pandas. Right. No, now suppose if you want to calculate some basic statistics on the numerical, all numeric columns, then you can call pd dot df or pandas data frame dot describe. So it describes like there are only two numerical columns inside the data which will load it. Then it is giving the basic statistics about the numerical column. So similarly, suppose if you are interested just fetching some initial 5 rows from the column, if your table is very long and you are just interested in looking at the first 5, then you can call df.head. And suppose if you are interested in just last 5 rows, then you can call tail, and number also you can specify like first 10 or last 10. Right. So now let us see how can we access data frame using some familiar Python list operations, like as we were doing indexing in NumPy array. Similarly, suppose if you want to do the indexing, or say suppose if you are interested in just fetching a single column from your entire data frame, then you can specify it like your name of your data frame, then inside square brackets the name of the column which you are interested in fetching. Like suppose if I just interested in just extracting the station ID column, so I can call it like df.station ID. Then suppose if you want to, from that column also you want to fetch a particular row, then you can specify a second index also, like first index is your station ID, and second index you are specifying second item, or you say if you want to extract the third or fourth row, you can specify like this. And you can do the slicing as well, like fourth to eighth column, etc. You can call it like this as well. And you can filter it by the value as well. Like suppose if you want to know, you want to just fetch the row corresponding to the station, where the name of station is equal to Naxat or whatever name it is there. Right, so you can specify df, then inside square bracket df, then which column you are looking for, df dash station is equal to the value which you are looking for. Like this, you can combine multiple and or whatever all you can do. Like this, you can fetch a single row as well from your entire table or column or combination of anything. This you can do. Then suppose if you want to apply manipulate the data, and suppose if you wish to say that, suppose if you want to calculate derive a new column from your existing columns, like here suppose if you have here, assume that we have a column named latitude, and suppose if you want to convert into say latitude in minutes, then suppose if you wish to multiply it by 60, then you can call it like df, your name of your column, multiplied by 60. So what it does, it picks up all values in your column one by one and multiplies them by 60, and the entire creates a new series. That series is assigned a name called latitude in min and attached to our main data frame. Right. Plus, there is something called index in a pandas data frame. So both series and data frame objects also define an index property that assigns an identifier value to each series item or data frame row. So like indexing means whenever you are attaching say a label to every row. So previously, if you remember about numpys, how we were indexing, we were indexing numpy just by using row number and column number like indexes. That's what the advantage of Pandas, because you cannot remember these numbers always. So for that, pandas we can refer every row also by a label, right? So that will be a label, that what we call index. So now there here you need not remember the integer index, because the remembering textual information for a human being is quite easier. So for that, whenever we are labeling our data or every row using a textual label, that we say that this is the index attached to that particular column. Like suppose if you want to fetch the index of entire station ID column, you can say that this is a integer index anyway, range starting from 0 to 150. Similar way you can assign a uh, string or string index also to every row in your column. And so then suppose if you want to reindex or you want to rearrange the rows in the different order, like second you want to go second whatever order, suppose the row with index 2, suppose if you want to make it as zeroth row of your data frame, you can call like by reindex function, and you can say then you can rearrange your rows as well, like by calling this function. And so now suppose if you want to sort your pandas data frame, then you can call the function df dot set sort values and specify here by the argument by which attribute you want to sort. Like you can sort it based on the two values into two columns as well. Then right. So like it will first sort it based on the first value, and if there is a tie, then it looks for the second one. Like this is the basic about data. Like those, there are basically two data structures, series and data frame. Now let's extend this pandas to the geopandas. So we can say that geopandas is an extension of pandas for handling specifically geometries, right? So pandas cannot handle geometry, so for that it is geopandas which will help you in applying operations or doing some geometric calculations on geometric objects, right? So Geopandas is an open source project to make working with geospatial data in Python much easier. So Geopandas, you can say, extends the data type used by pandas to allow spatial operations on geometries. Like you can query the geometries, merge the geometries, or whatever kind of operation you can do on the geometry. That those all operations can be done using Geopandas. So the primary data structure in pandas also, like the basic what we call geoseries. Every column we call geoseries, and entire table we call geo data frame. So as in our vector introduction, so similar to this, geoseries also has these three basic geometry objects, like you can say point, multi-point, line, or polygon. Then geodata frame is a tabular data structure that contains a geoseries. Right, so when we say that pandas data frame and geopandas geo data frame. In case of pandas, we have just attribute columns, but in geopandas there will be an additional special column called geometry. So that will hold the geometry, like whenever, as we said that in vector data, we are representing the features using their geometry, right? So maybe using their location on the surface of Earth, right? So in GeoPandas, there is a column called geometry, so that holds the geometric information about geometric information of all these features. Like a GeoPandas more than one geometries as well. But out of these geometry, only one will be designated as the geometry. Other can have different can have there can be multiple geometries existing, multiple geometry columns existing in a geodata frame, but only out of those all columns, only one be designated as geometry column. Right, so now let us see how do we read and read. Actually, basically today we'll focus on the reading vector data using GeoPandas. So as in case of raster data, so vector data also comes in multiple formats. And so we will briefly talk about different or some very popular uh, very popular data popular file formats for vector data, right? So one of the popular file format is ESRI shapefile. So ISRI shapefile is a simple non-topological format for storing the geometric location and attribute information of geographic features. Right. So in the limitation of ISRI shapefile is that it is non-topological. You do not know the order of say edges or vertices in your data. Right. So that is like this is a non topological in order. The shapefile format defines the geometry and attributes of geographically referenced features in three or more files. Right. So shapefile contains all information about the features, maybe their location and their attributes. That what we call non-spatial data. So then in shapefile, all this data is stored in multiple files, and every file will be storing some relevant information, like the .ssp file, that is the main file that stores the feature geometry required, feature geometry that it is essential. Then .shx is the index file that stores the index of feature geometry. This is also a required file. Then .dbf is the dbase that contains and stores the attribute information of the features. This is also, these three files are compulsorily required. Like if you don't have any of these, if any of these three files is missing, either your Geopandas or any GIS software will be unable to open and interpret these files. Then .sbn and sbx files are stored for spatial indexing. And so then .prg files that store the coordinate system information about the features in your file. Then similar to this, there are another important or popular format is GeoJSON. So GeoJSON is as like Pandas is GeoPandas is extension of Pandas. Similar way, GeoJSON is extension of JSON for geospatial data. So GeoJSON is a format for encoding variety of geographical data structure. GeoJSON object may represent a region on the space or maybe on the earth, or may be bounded by an entity. Plus it can store non-spatial data also, like maybe the attributes, other attributes. Like suppose if you are representing the city of Dehradun, right, and we want to specify in the property what is the name of the city. Like so now you have a type feature. Feature is saying that geometry, like it is telling that this particular feature is at this longitude and latitude, and the like there is another property called properties that will store the non-spatial attributes, like the name of the city, or they say you want to store the average temperature of the city during certain period of time and something like this. Then another format like geographical markup language, MongoDB, Keyhole Mark, KML, OGSWF service, and all like this. There are so many other formats as well for storing vector data, right? So actually for this demonstration, I will actually some of the data I will be using existing save files available with me, and some data actually there is a very good package called Geo Data Sets. So that also has multiple vector data available in this, so you can use that as well for demonstration, right? So first thing what I am doing, I am just installing Geo Data Sets, because Geopandas comes nowadays pre-installed in Google Colab, but this geodata set does not come. So because of that, I am just first installing geodata sets. So then it stores these data in some specific location. So if I go to this, so you can check once where does this store this data, right? Now suppose if you want to read the file, right? So so in I will just see. So in this geo data sets, there is a function called get underscore path, and if you pass the ID of your data set, it retrieves the actually the path of your vector file, like where this once you download, where it goes stored. Like if I say vector. So here you can see the file got stored in root cache geodatasets nybb.shp. There is this file available there. Now suppose if you see that how do we read this file using Geopandas. So like Jidal has a function called jidal.open. So in Pandas we saw a function gpd.read underscore csv. Similar to this in Geopandas also is a function read underscore file, and you need to specify or pass it an argument called the name of your file which you want to read. Right now it has red. Now if I see the type of GDF, it says this is a Geopandas geo data frame or geo data frame ultimately, right? Now in this, suppose if you want to set the index, like suppose if every row, now if I see this GDF, how does it look like? Now if you see this file has these attributes like say the code of the borrow. Maybe this may be the way of organizing some wards might be in the United States. I'm not sure about this. So borrow code, then what is the name of that borrow and what is the length of the shape area, and this is the geometry, like this is the geometry of this particular feature, like where on the surface of earth this particular feature exists. Right now, suppose now if you see the indexes, so the name of rows in all of these, name of rows is in an integer. Now suppose if you want to change this index to say, instead of integer you want to change them by a name like borrow name, so that then suppose if you wish to fetch some information about some particular borrow, you can then you must be able to just specify by its name. You need not to search for the index first, right? So by gdf.set index, then here, actually this is in already maybe in projected coordinate system. Suppose if you want to calculate the area for all of these borrows, like here you can see that we have specified their locations, right? So we know that where this particular borrow starts and how does it, what is the shape of the boundary of this. And suppose if you want to calculate the total area of this borrow, right? So then you can create, like suppose for all the features in a geoseries, suppose if you want to calculate the area, right? So now in the or data frame we are adding a new column called gdf dot area, then where we are storing gdf dot area. So what this gdf dot area function it does, it looks for a geometry column first, like which of the geometry column in my data frame is assigned the designation of geometry. So then gdf dot area, what it does, it picks up all these geometries one by one and calculates the area of all these geometries. Like so here if I call gdf dot area is equal to gdf dot area, I am creating a new column in by name area and just calculating the area there. So like here you can say that you can this quite easily we can calculate the area of all the picture. But while calculating the area, first you need to ensure that your data is in proper projection system, otherwise you will be getting wrong values, right? Then suppose if you want to calculate the boundary and centroid of all of these features separately, like so then you can create, like suppose here what we are doing, we are creating a new column called boundary. In that we are calling gdf dot boundary. So it calculates the boundary of all of the features one by one and assign them to boundary column. Then similarly you can calculate the centroid, right? So you can say that these are the boundaries of all these features, then you can visualize them as well, and whatever you wish to do, you can do this. Then these are whenever we want to represent the centroid. So the natural choice for representation of centroid is a point. Then similarly, suppose if you want to measure the distance, we can also measure how far each centroid is from the first centroid location. And so as we can say that there are multiple features in our shape file. And suppose if you want to calculate the distance of each centroid from the first centroid in our table, right? So what we are doing, we are just fetching the first point by calling gdf.centroid.ilog. Ilog is an for integer indexing. Like suppose if you do not know the what you call the textual label of your textual index of say your data, then you can index them using integer indices also, like gdf dash centroid.ilog 0 will fetch you the first row and first column. Then right, then you can calculate gdf centroid dot distance, our geo series, right? Geo series which contains geometry dot distance, if you specify the dot distance and from where to calculate the distance. So we are at argument we are passing first point. So for all the features in our table, the distance from the first point will be calculated and the entire thing will be assigned in a new column called distance, right? So here you can say that this is the name of the borough and their calculated distance, because Staten Island was the first value, so it is showing 0, and like these are the distances of all these boroughs from our centralized borough. Like so, that like suppose if you want to calculate the mean distance, you can call GDF distance dot mean. So it says that the mean distance is 76,140. It may be meter, kilometer, or most probably meter only, right? So this was all about reading vector data. Now suppose if you want to create some maps from the data, GeoPandas also can be used to plot maps, so we can check how the geometries appear in space. Right now, if you are just seeing the numbers as some multi-polygon, then we cannot imagine how the data will look like, right? So suppose if you want to display them on a active geometry, then we can call, there is a function called directly in our pandas data frame, we can call the function dot plot and specify there the column based on which you want to color these different polygons differently. Right now, if I call gdf dot area and legend, if I say true, now you can say that all these are the all borrow maps in our data sheet. And similar way you can do it for any other vector data as well. Then suppose if you want to explore the data interactively, right? Now this is not interactive data, so this is just shown you on a static map. So suppose if you want to use or display it on something called you want to interactively explore it, then there is a function in pandas, geopandas for you, that is called explore. So what it does, it overlays your geodata frame on an map. So here I'm telling gdf.explore and color like make the color place map based on this attribute in our data. And if I say legend is equal to false and run it, now you can see that a nice interactive web map will be created. So you can see that just with a few clicks, we are actually, the loading of the map takes time. So here we go, and we can see that anyway once we come back, then we will see it once again. So it will be displaying on the backend base map, it will show as OSM base map, and on the top of that it will overlay these boundaries. Then similar way you can calculate, suppose if you want to set a different geometry, suppose instead of a boundary you want to set the centroid of each of these polygons to be designated as the geometry column of the column, then you can specify it like this also, dot set geometry, and specify the name of column which will be the designated top level geometry in our, so like this you can do. Then you can create the plot as well from the geometry and plot like this. These were our original files, and these are the dots or centroids of all of these polygons. And like this you can create, suppose if you want to calculate convex hull of a geometrical series, then you can call the function gdf dot convex hull, then it will create the convex hull of the convex hull based on designated geometry column, like whichever column we have designated as the geometry of our column for convex hull, around all these features will be drawn. Now suppose if you want to draw this chart, so it says the convex hull. So if I see GDF, so convex hull did not get assigned. So actually what happened, I set the geometry column as the centroid. So we cannot calculate the centroid around the column. So I will just now make the polygon as again as the geometry of my data frame. GDF dot centroid as my border. So what are the column name? I'll just inspect. And the geometry is boundary column. I will just set once again at geometry. So let me check if the geometry has been set correctly. So as now you can see that there are more than one geometry, one columns which contain geometry in our data frame, but out of these only one we will designate as the geometry column. So if I call GDF dot geometry, now you can say that geometry the boundary column has been designated as the geometry column. Now I can call now if I see GDF new column with the convex hull must have been created there. Right now, then suppose if you want to see it visually, how does it look like? You can call it like so. These are the geometries, and we have created a convex hull around the geometry. Like so, similarly, suppose if you want to create buffer around each of these geometries. So in other cases, we may need to buffer the geometry, right? So for that, there is a function called in geodata frame like convex hull. There is a function called buffer. Right, so buffer you can create around geometry or around point as well. Like now we'll suppose if you want to create a 10,000 meter buffer around all of these centroids. Like I will once again set the centroid as the geometry. Go back and now suppose around each of these centroids, suppose if you want to create a buffer. Right, so we need to call the function gdf dot buffer. So what it will do, it will pick up the geometry column and around each feature in that geometry column, it will create a buffer. Right, now if I visualize this, now you can say these were the points, centroid points, and we have tried to create a buffer around all of these points. Right, now suppose sometimes what might happen, you generally whenever you get vector data or shape file, because there in the shape file there will be multiple files in that. So generally what we get the data in zipped format, right, in the zip format. So Geopandas can directly read a zip file, like it can automatically unzip the file itself. You need not first unzip then read. So suppose if you have your data available in a zipped folder, then that also you can directly read. Like suppose my data, this is the shape file of state boundaries of India that is available in zip file. Then I can just call like gpd.read file. If I specify the name of directly the zip file as well, I need not unzip. But inside that there must be the same file state underscore boundary dot shp file must be there inside this zip. So then it will can easily open. Like if I see the states. So now here you can see that these are some non-special attribute, and this is the special attributes of the data. Now suppose if you want to plot how does it look like, then you can create a nice plot as well from this. If you need to call just a function dot plot. So with dot plot you can plot the all geometries, then you can change colors and etc. that we will discuss tomorrow. Then suppose if you like sometimes what might happen, your zip file might contain multiple shape files, right? So suppose if you want to read a particular shape file from a zip file zip file, like in your zip file, suppose there are multiple shape file inside that. So that also you can specify. Like suppose I assume that I have a file administrative boundary database dot zip. Inside that there are multiple shape files available. Out of that, suppose if you want to just read major towns dot shp shape file, right? So that I can specify like my file name. I will be specifying like this: name of my zip file, then an exclamatory mark, then the name of my shape file, right? So we will just specify like this. Then I can read a particular shape file as well from the zipped archive without unzipping them explicitly. Right. So like this, suppose if I plot this administrative boundaries like this, you can see that these are some major towns or cities around India. Then using Geopandas, you can read a file from a web URL as well. Like suppose if your URL is available in some GeoJSON format somewhere on the web. So you don't want to download it and you just want to directly read it like you are reading a web page. So Geopandas can read data from a web URL as well directly. Right. So you in a variable I'm storing the URL of the file where the data is available. Then gpd.read underscore file and pass it the URL. So depending on what kind of argument you are passing to a read file function. So either you can read directly a shape file, GeoJSON file, or a zipped folder, a shape file inside a zip folder, or directly from a URL as well. You can read. Right. So suppose if I read it, so you can this is the shape file which we have read. Right. So similarly, suppose if your data is very huge, and you just want to read a particular subset of the data, right? So either one way was just read it, then you filter it, and another one is while reading itself, you can filter your data by specifying different different like either you can specify some mask like okay just read the polygons which are intersecting this with this particular geometry as well or something like here I am saying that I am creating a mask by using state boundaries dot shape, right? Now so in the second file I have some say district boundaries dot shape. Now I just want to read the from the district boundaries dot shape only the districts of say state Assam, right? So I have created a mask. I have created another mask by the geometries of from state boundaries. And here what I am doing here gpd.read file. I am trying to read the entire file. Then the mask I am specifying as GDF mask, where in my mask the attribute with the column state has the name Assam, right? So it will just read the only the district boundaries of the Assam state district boundaries only, right? So if I see this, so out of all district boundaries, it has just fetched or read only the districts which has the name as Assam, right? So these like all the districts of Assam. If you can read it like this way as well. Then similarly, you can specify the bounding boxes as well. Suppose if you want to know that instead of reading this entire file, just read the features which are intersecting with some particular bounding box. Right, so then you can specify gpd.read file name, and specify your bounding box as min-x, min-y, max-x, max-y. If I read this, so this may be like some part of India, right? Karnataka or somewhere. So then you can specify like suppose if you want to read from you like your entire data is represented as a table. Now you want to represent say some only some specific rows only you want to read like from the rows 80 to 180 only. Suppose if you used to read, then you can specify then like a rows slice 80 to 180. So just read 80 to 180 slice, right? So then it will look like this. Right, so I think my explore must have come by hope. Right, now the explorer has loaded the map as well. Like here you can say that you can interactively make quite good, nice interactive maps just by calling the explore function. Like so, the entire OSM map has come on the background. Then similar way you can filter by columns. Like if you want to just read a single column from your table, then you can read it like this as well. Like geometry and only one column will be fetched. Then you can specify it like a where clause as well, like gpt.read file name where state is equal to Uttarakhand. Like you want to write a query, you want to read a file, and you want to specify that just fetch the rows only where the name of state column has the value Uttarakhand, right? So you can specify the query like this. This way you can read in multiple ways. Then you can read multi-layered files also. Some data formats are there. Some vector data formats allow only storing only one layer of geometry, like one, or suppose either you can store all lines, all polygons, or only single layer. But some formats are there, like geodatabase, where you can store multiple layer, like one layer containing all the point layers, one layer containing polygons, another one containing lines, and so on. Right, so then the reading that also is the same. Right, so GPD does list layer. Suppose if I list layers, if you say, then if I say layers, so this particular file has two layers. One is LULC polygons, another one is lines. So the reading file is also same, gpt.read file. Then if you plot it, now here you can see that there are two layers. One is on the back side, that is as geometry. The another one is like a buffer on these geometries. Similar way, you can read a GeoJSON format also, GeoJSON format as well. Only the same function, a read file. Right, so then you can subset as well, as we have done, like you want to subset, extract Tamil boundaries of Tamil Nadu only, or cities of Tamil Nadu, whatever, based on the column, you can subset them as well. And suppose if you wish to explore that on an interactive map, all the districts of Tamil Nadu state, like this, so beautiful map you can create just with a single command. Right, so then all these attributes are shown, like whatever columns are there, so they are shown on this separately, right? So then you can color them based on these things. You can create nice interactive maps using pandas quite easily. So with this, we come to the end of this session. So today we discussed what vector data is, and then in the second part we saw how do we read different vector formats. Then we, like, maybe a shape file or a GeoJSON file, or then we discuss how do we filter them, either maybe after reading the file or while reading itself. And the second part, we saw how do we create maps. Then we did some basic geometrical analysis on the data, like calculating the buffer around the geometries, or say calculating the distance from one point to another point, calculating the centroid of different geometries, and like this there are multiple functions available in the GeoPanda. So in the tomorrow's session, we will discuss some more advanced geometric analysis on the vector data. So thank you very much for attending the session. If you have any questions, you can post them on the chat box. I will try to answer them with the best of my knowledge. So thank you.